welcome to Fluids Friday on Curly Carbocation. If you like short form chemical engineering content, please subscribe and stay tuned. I don't think there's anything that American engineering students beef with more than the standard unit system. You might also hear it as the standard units, Imperial Units, or American Units, and it's called Imperial because it came from England, and then they make fun of us for using it. The issue with this beefing is not the units themselves, but when you go into the workplace where everyone that you work with in the United States is used to standard units. The biggest issue is that pounds is considered a force, but people will also think of it as a mass, and it's your job as the engineer to know the difference between the two and not just mathematically, but physically understand the difference. So my fluids prof introduced us to this constant G sub C, and this constant ruined my life so many times, so listen closely. G sub C equals 32.174 pound mass feet over pound force seconds squared. This is a conversion factor. And you may just be looking at the units like, what the heck do I do with this? Going back to physics, force equals mass times acceleration. And from SI units, we know that a Newton equals a kilogram times a meter per second squared. So what happens when we transliterate this into the imperial system? The transliteration would be that pounds equals slugs times feet per second squared. Slug is the unit of mass in the imperial system, and feet per second squared is the unit of acceleration, while pounds is the unit of force. But tell me, how many times have you used slugs outside of physics class? The literal only other time I used slugs was in differential equations, only because the professor thought that imperial unit names sounded way cooler than SI. So with this slug problem on our hands, we have to use pounds mass, literally because no one's going to understand you when you use slug. Remember that the acceleration due to gravity is 9.8 meters per second squared and is also 32.2 feet per second squared. So really, the only difference between G and G sub C is the arrangement of the units over here. Sometimes I also like to write down G sub C as 32.174 over 1, so that whenever I have to use this conversion unit, I know when to flip everything. The most common place where you are going to use G sub C is in the Bernoulli equation, which I'm going to talk about next week, next Friday, so tune in then. If you like this video, please be sure to share this with a friend who needs it this semester. And I will see you all in my next video. Bye guys!